Welcome back to this week's episode. Last week, we did some painting, we started some electrical work, and we also jumped on the roof to install some solar panels. In this week's episode, we begin wall mounting all of our electrical components, but here we don't move on to wiring our electrical because first we needed to build something to keep our battery above freezing temperatures. So be sure to give this video a thumbs up and subscribe to our channel so you can see our videos every week.
So our solar power actually comes out these two wires. So it's currently a live wire. Basically it's live by whatever power is coming out of our panels at this moment. Probably not a lot, it's pretty cloudy, a little overcast. It's actually extremely windy and it's raining a little bit. I can see the rain starting to hit the windows. But anyway, you can see here, so this is our electrical wall here. So I've got to figure out where I can mount our positive bus bar on this wall, where I can mount the negative bus bar on this wall, and we have a charge controller. We have a Bluetooth module 4-hour charge controller, and our inverter is then going to go here on the wall. Yeah, let's see if we can't fit this on the wall. Becky has the GoPro downstairs. She's actually doing a little bit of painting right now on our, we'll call them bed rails. These are the legs for the bed.
Yep.
Essentially. So basically what we're doing is these are going to be, we'll call these the vertical supports. So it sits on the floor, as you can see. So the weight is transferred right down into the floor, and there's going to be a rail that goes across.
These are the screws we're using.
So we spent all day out here working on the van, made a lot of progress.
These are our bed rails. What we also did was he wall mounted our electrical. So we have two 12-volt fuse boxes. We still have some space to expand if we need to. We have our Renogy solar charge controller. This is the 40 amp one. It's an MPPT charge controller. And then we have our bus bar master switch cutoff thing. We also have our LINAC lithium battery. And this technically won't be here. We left a lot of space, so we probably know we will for sure get one more because we only have 100 amp hours right now. So we will for sure probably get one more, but we also have room to put a third one, so we left enough space to expand with that.
But also up here you'll note that there's no wires coming off any of the bus bars yet. So what's going to happen is we have our power from our solar panels coming out of the wall. This is the negative, so it just goes right into the charge controller, and then the positive goes through a 40 amp fuse before it goes into the charge controller. So then we're going to have the power coming out of the charge controller. It's going to go up to here. It's going to go through this fuse, and this one here is going to come across and go to the positive terminal on our battery. This fuse is going to be for our inverter, which is going to be located over there. So we're going to have to run a wire from here across and down to the inverter. This one is going to be for one of these two, as is this. So both of these are both going to run over to these two. And then this one here is actually going to be connected to our alternator. So we're just going to have to kind of run that wire across and up to there. And we'll obviously do our best to make that look nice and clean. And that takes care of the positive side of all the electrical. We also have the negative side of the grounds, which we are probably going to make a bus bar and put it here. It's not a lot of space, but if we can put it here, that just frees up a lot more space for us on this whole wall. Pretty happy with today's progress, honestly. I think we got a lot of stuff done, and catch you guys tomorrow. All right, welcome back. So today, well, let's just talk about something really quick. Lithium batteries. Can't charge them below freezing. So there's a couple really good things about lithium batteries compared to AGM batteries or regular deep cycle batteries. And the main ones is that you get 100% of the useful amp hours out of a lithium battery. The reason we went with this one is because this battery, or lithium batteries in general, when you start it, it's at, I think, 12.8 or 13.2 volts or something. And essentially it stays at the same amount of volts until it's at about 5% battery left. So they work extremely well for giving out a constant voltage that doesn't drop until essentially the battery's dead. Now we do have a monitoring system in the van that we can tell what percentage the battery's at, but you can't charge the battery if it's below freezing. So in order to combat that, we actually ordered a few things. They arrived today. So we're gonna do our best to build an enclosure for the battery. This is the same styrofoam that we use on the floor. And essentially we're just gonna build an enclosure around the entire battery so that it's kind of sealed in its own compartment. And then we're going to take a sheet of aluminum, and it's actually going to be about the same size as the bottom here, and stick it right on the battery. So the whole purpose of having that sheet of aluminum is that it will kind of act as a heat sink. And then, where are they? Here they are. We have a few little things. So, this right here. This is the heating element off of a handlebar grip for either a snowmobile or a four-wheeler. So I think this is 15 watts, 12 volts. Obviously everything's 12 volts that we're using. So this guy's gonna be the heater for our battery. So this is gonna mount, or essentially glue onto an aluminum plate that's gonna act as a giant heat sink, which is then going to sit on the bottom of the battery to try to heat the battery, essentially. So that's all fine and dandy, but in order to turn that on, we would have to flip a switch to either say, okay, we wanna heat the battery now, or what you can actually do is, I didn't even know this was a thing, but it is. We got this little guy. Very, very tiny. Doesn't really look like much. The way that this thing works is, so yeah, you hook it up to your battery, so positive and negative on this side, and then this is essentially your switch. So you would obviously, you have to ground out this with the ground, and then your positive wire will go from your power into this, and then from this into this, which is your heating element. And this whole contraption is controlled by this little thermostat. So you could set this to have a couple different parameters. One, we'll go over this, but one of the parameters is when this will turn on the power. So I think we're gonna set this so that this essentially turns on around 4 or 5 degrees, and we'll start heating this. And then once this gets up, this whole setup here, mainly this, the temperature sensor gets up to about, I don't know, probably 8 or 9 degrees Celsius, we'll have it so it turns off. And essentially that's gonna heat our battery. So we'll link these down below, but got this on Amazon. We actually got 2 of them for about $15, and you can do a whole bunch of different things with these. Anyway, this is the board wired up. So it's off right now, nothing is being heated. And when I throw this in our ice water, it cools down to 5 degrees, heater turns on. You can actually tell when the relay's on by that little light to the right. And when it turns power on, it actually starts heating this. So I know you guys can't see this. This isn't necessarily hot, but it is definitely warm. So our temperature's now down to 4 degrees. And then boom, 8 degrees, it turns itself off. So this is how we're going to heat this battery. Initially I thought I might only use one of these heating pads. We got 2. I might use both. One on either side of the battery possibly. Not quite sure yet, but we're gonna figure something out. We essentially we just want to have this battery above freezing all the time so it can charge and it doesn't ever get, you know, into a dangerous temperature range. So I don't quite know. I set an alarm for this thing to actually set out a noise or a signal. Not quite sure what the alarm sounds like, but it's supposed to turn on when this hits 30 degrees, 30 degrees Celsius that is. So hopefully, you know, if this was ever malfunctioning and it was getting really, really hot, we would be notified by that alarm.
So that's a wrap for this week's episode. So next week, we'll install the battery box and finish our electrical wiring. We'll also begin building the box that our fridge will sit in, which will also double as a bench seat. Be sure to give this video a thumbs up and subscribe to our channel. See you next week!